Okay, completing a square. We'll recap what we've done so far, and we'll apply it to a few word problems. So let's complete the square. Remember bracket, the two x terms. Now we need half of 16, which is 8, squared, 64. Y equals x squared plus 16x. Remember to add and subtract 64. Okay, get the negative 64 out of the bracket. Okay, by multiplying by 1. And then you need to factor the perfect square trinomial that you have created. Remember, half of 16 square root of 64, or that number that you squared, which was 8. Okay, and the vertex will be negative 8, negative 61. Okay, notice this one, the a value is negative 5. So when we factor out, we're going to factor out the negative with the 5. So negative 5 will be our factor. Remember, both signs inside the bracket will change. So it'll be plus 6x. Now 6 divided by 2 is 3. Squared is 9. Plus 15. Okay, remember, you gotta get that negative out of the bracket. Remember this case, we're going to multiply it by negative 5. So negative 9 times negative 5 is going to be plus 45. And then factor your trinomial. X plus 3 plus 60. Vertex, negative 3, 60. Again, another negative. So pause this one, give it a shot. Factor out negative 3. Plus 4 is left. Okay, 4 divided by 2 is 2. Squared is 4. Plus 4 minus 4 minus 17. Remember, you have to multiply the negative 4 by negative 3. When you do that, you will get 12. Then factor your trinomial. X plus 2 squared minus 5. Vertex, -2, -5. Okay, for this one, notice that 4 does not divide into 6 evenly to give us an integer value. So if you want, you can leave it as fractions and work with them, or you can switch it to a decimal. So step 1, common factor out that 4. -6 divided by 4 is -1.5. We're just going to use decimals for this one. Okay, half of 1.5 is -0.75 squared is 0.5625. So remember, add and subtract it in. That number is the same as 9/16 if you're using fractions. Now we have to multiply by 4 to get our negative value out of the bracket. Which equals -2.25. Now we factor it. And just remember the number that we squared, so that -3/4, that goes in the bracket. -1.25. So the vertex is 3/4, comma, -1.25. If you're using fractions, that was 3/4, comma, -5/4. Okay, let's look at a word problem. So in this one, a model rocket is launched straight upward with an initial value of 200 meters per second. The height of the rocket, h, in meters, can be modeled by the following equation, where t is the time elapsed in seconds. So when you read this question, we look for like buzzwords to tell us what to do. See the word maximum? So maximum means vertex. So whenever I see the word maximum or minimum, I think vertex, vertex, vertex. How am I going to get to the vertex? I'm going to get to the vertex by completing the square. I'm in standard form right now, and I need it in vertex form. So we need to common factor out that -5. T squared minus 40t. Now, half of 40 is 20. Twenty squared is 400. So remember to add and subtract it in. Get the negative out of the bracket. Multiply by -5. That'll take it outside the bracket, which will be 2,000. And then just complete the square. So now to answer the question, it said, what is the maximum height the rocket reaches? Put a little therefore statement. The rocket reaches 2,000 meters. Okay, it reaches 2,000 meters. If it asked when does it reach this time, like when does it reach this height, it would just be 20 seconds. Okay, so the vertex gives you that answer. Okay, a little bit harder question. So it says Randy's building a fence at the side of his warehouse. He has 120 meters of fencing and plans to use the side of the warehouse as one of the sides of the rectangle. So what you want to do is my suggestion. So when we look at 120 meters, that is a perimeter. So we need to come up with a perimeter formula for his rectangle. So you might want to label it. So width, length, width. So the formula is going to be 1 length plus 2 widths. And if we sub in what the perimeter was, 120 meters equals L plus 2W. Now you need to isolate one of the variables, so we'll probably isolate L in this case. So we'll end up with 120 minus 2W equals L. So we just pop back to the equation for a sec. It says, the question asks, what are the dimensions of the maximum area? So then I want to go back and I want to use the area formula. And I know the area of a rectangle is just length times width. So if we sub in our length and widths, width, and the length is just 120 minus 2W. Now what you want to do is you want to distribute your W through. So we're going to have 120W minus 2W squared. Probably want to rearrange this equation. So area equals negative 2W squared plus 120W. So when we went back to the equation, or to the question, it says the maximum area. To us, that means, oh yes, the vertex. So we need to complete the square. take the negative 2 out. W squared minus 60W. Negative 60 divided by 2 is 30. And 30 squared is 900. So area equals negative 2W squared minus 60W plus 900 minus 900. Multiply negative 900 by negative 2 to get the negative out of the bracket. Area equals negative 2 bracket W squared minus 60W plus 900 plus 1800. Now just factor it. Negative 2 bracket W minus 30 squared plus 1800. So now we know that the dimension for the width is going to be 30 meters. So if I just go back up to, let's erase this here. If I just go back up to my perimeter formula where I isolated length, I can sub in the value for the width, which is 30, and we'll figure out that the length is just 60 meters. So therefore the length is 60 meters and the width is 30 meters because the vertex was 30, 1800.